Okay. Oh, am I back on YouTube? Okay. I'm having some difficulties here today. Anyway, yeah. So yeah, going back to the final exam. If we do a final exam, it'll obviously be some kind of digital format. And I don't know exactly what that digital format would look like. But I'll certainly keep you informed with how that is going to work out, and what that's going to look like as I learn. Any other questions before we move forward? No, no test for chapter 4. Yeah. Yeah. Any other questions? No? Okay. Okay, let's jump into it. So we're going to be talking about radicals. And radicals are something that we've seen a little bit of already. So radicals is like square roots and cube roots and things like that. Yeah, what we're going to do is we're going to talk about simplifying radicals a little bit. And we're going to talk about something called mixed radicals and things like that. So we're going to be basically covering section 5.1. So let's jump right into it. So I'll call this chapter 5.1, and this is on radicals. What do they call it? Is it it's working with radicals? Working with radicals. Working with radicals. Okay. So yeah, let's just jump right into it. So let's talk about. I want to talk about. First of all, I want to talk about like the radical symbol and what it means, because I think that there's a lot of misconceptions about radicals, and I tried to address some of them when we were doing quadratics, because quadratics, like radicals just naturally come up in quadratics. But yeah, we'll talk about some kind of the misconceptions. So first of all, let's talk about what a radical is. So if x to the power of n is equal to a, then the nth root of a is equal to x. Okay. So that's the gist of it. Is it's kind of like the opposite of an exponent. So it's kind of like a way of undoing an exponent. So let's talk about a little bit about what these symbols mean. So so I'll write symbolically. I think there's actually one L. Symbolic. How do you spell symbolically? Symbolically. There we go. Symbolically, we have. Okay. Well, I'm just gonna write all the different terms that we might need for this section. Okay. So this thing right here, this is called the radical symbol. This guy right here, this A, the thing that's inside the radical, we call the radicand. And this guy right here we call the index. Okay? So that's our index. And the whole thing, like this entire thing, this is called the radical expression. Okay, so that's our radical expression. So those are all the terms that we're going to need. And what I'd like us to do is just do a few simple examples, just to start getting a feel for what radicals look like and how they work. Okay, so I know that I've got the textbook right beside me here, and there's a bunch of really good examples, and I'd like to do those examples at some point soon. But I want us to first warm up a little bit, particularly. I want to talk about how positives and negatives are related to radicals, because there's a lot of misconceptions here. So I want to go through these misconceptions with you. So let's work through a few simple examples. So let's start off with this one. Let's do, let's simplify. Let's simplify. Let's do, let's do the square root of 4. This is one of the more simple ones, okay? Now, this is where the misconception happens the most, is that I think a lot of people say, oh, okay, so what I'm looking for all the values whose square is 4. And that's actually not true. The square root of 4 is just equal to 2. And yes, 2 squared is 4, and that's why we get that. But some people might say, so I'll write, you may be tempted to write the square root of 4 is equal to plus or minus 2, and that's not actually true. It's not actually true. So there's two things that are really similar. Okay, so these are similar but different equations. So if I were to ask you to solve x squared equals 4, and I was to ask you to solve x equals the square root of 4, these are different. These are not the same. Not the same. So this first one over here, this one has two solutions. This says that x is equal to positive 2 or x is equal to negative 2. Because when I square either of these numbers, I'm going to get 4. Because 2 squared is 4 and negative 2 squared is also 4. Whereas this one right over here, this has just one solution, and that is x equals 2. Okay? So there's a major misconception that often a lot of people think that this is the same as this. They're different. These are different equations. So you might say, okay, well, hold on a second. I thought that we referred to the solutions to this guy as roots. I thought that we said that when we were looking for solutions to this, we'd be looking for roots. Or in other words, we'd be looking, because this is a square, wouldn't this be the square root? So how is a square root different than the roots of this equation? Because here we have 2 roots, right? We've got plus and minus 2. I know that from working with quadratics. I've got a square, these are, because it's a square, so I'd be looking for square roots. And where this one, I'm still calling it a square root. Well, the thing is that this isn't actually, like, the technical term for this is not actually called the square root. This is called the principal square root. Okay, so the principal square root just means that you're going to take the positive version of it no matter what. So obviously these two things are related. These two sort of yellow cloud things that I circled, they're very closely related. The idea is that we're taking the root of a polynomial, or in this case, a root of a square polynomial, or root of a quadratic. But this one over here we call it the principal square root. And anytime you see this square root symbol, that is talking about the principal square root, where we're just thinking of the positive version of it. So sometimes, yeah, you do have to deal with positives and negatives. However, when you're just asked to take the square root of a number, we're only ever talking about the principal square root. So I hope that's clear, because they are in fact different. Let's do a few more examples. Let's try something that looks like this. Let's do the cube root of 8. Cube root of 8. Okay. Well, that's just 2. Okay. Let's do a few more. Let's do the cube root of negative 8. Okay. Cube root of negative 8. Well, that would be negative 2, and that's because negative 2 to the power of 3. That's negative 2 times negative 2 times negative 2, which of course is negative 8. Okay. Let's try something like this. Let's do the square root. I guess I don't need to put the 2 there. Let's do the square root of negative 4. And this has no solutions. So this we would say has no real solution. And what I mean by real is like a real number, as in this set. It has no real solution. Maybe later on, if you decide to go to university and study math, you might learn about the set of complex numbers, which we denote with this fancy C, in which case you'd learn that this actually does have a solution, but it's a complex number. The solution to this one would actually be 2 times I, where I is what we call the imaginary number. Okay, couple more examples just to sort of clear up some misconceptions. So let's simplify. Let's call it square root of x squared. Okay, square root of x squared. Okay, and here's another source of some misconceptions. I think that a lot of people see this and they say, oh yeah, well they undo each other, right? It's just the square root undoes an exponent of 2, so this is just equal to x. Okay, and you're almost right. You're very close to being right. But here's where you'd be wrong if this is what you said. So x is a variable, right? X is a variable which can take on any value, right? That's the whole point of a variable, is that we don't know what it is, right? It could be anything, which could be anything, right? What if x is negative? Like, what if it's less than 0? Well, let's see what would happen in this case. Well, let's say, for example, let's say that x was equal to negative 5. Okay, so if x was equal to negative 5, I would get the following. I would get the square root of negative 5 squared, and that's going to be equal to the square root of 25, right? Because negative 5 squared is positive 25. And then I would get positive 5 back, right? That's not the same thing as negative 5. Very similar, right? Like, one is obviously related to the other, but not the same thing, right? So the thing that I'm missing here is my absolute value symbols. So we touched on absolute value very, very briefly. Yeah, so the absolute value just means take the positive version of it. So so the square root of x squared is equal to the absolute value of x. So these are all just sort of very small technical examples that I'm doing that aren't super deep and conceptual. It's kind of like I'm just kind of covering, it's almost like spelling mistakes. You'd be surprised though how many people make these mistakes. Even people who are in university, like I've seen people in university make these mistakes. Math teachers often make these mistakes. So it's really important to sort of go through these small little examples before we sort of jump into the deep end and start attacking the more complicated ones. Because these little things, they come up, and if we keep making these little mistakes, then that's not going to be good for us. Okay, so let's keep going here. Okay, just following up with some of the chat. If this class actually starts at 7, I'm gonna riot. Don't worry, we're not gonna start at 7. We are just gonna stick around at our same spot. Okay, so it looks like we have some people on YouTube and some people on Discord, so that's great. Okay, I think that those were the main examples that I wanted to do. I'll try a couple more actually that are kind of on the smaller end. So let's try this one. So let's simplify something that looks like this. Let's do the square root of x to the power of 3. Okay, we'll simplify the square root of x to the power of 3. I also want to show you just a little, it's not so much a trick, but it's kind of like a piece of notation that I find really useful. So sometimes when you're drawing a square root, you might just kind of like do something like this, and then it's not really sure where your square root starts and where it ends, right? Like, is the exponent of 3 underneath the square root symbol, or is it outside the square root symbol? So a professor once taught me to do this, and I like to do this every once in a while, and that's to do the top line and kind of go past the point where you want it to go, and then put a little notch there, and that makes it very clear where your square root starts and where it ends. Because if you just have like a little line, sometimes the line is like too long, sometimes it's too short. Like, you can imagine, like, I could have something that looks like this, like the square root of a times b. Is that the square root of a times b, or is it the square root of a times b, right? So if you just have a line that looks something like this, like, what does that even mean, right? But if you put a notch there, then immediately you know, okay, well, the b is not inside the square root. So just something to keep in mind while we're learning about radicals. Okay, so let's simplify this. So the first thing that I'm going to do is I'm going to think about well, what my index is, right? Like, what's the index on my radical here? And that would be 2. Okay, so that's 2 right there. So so I got a hair in my mouth. It's kind of gross. Ugh. Cats. Okay. So my index is 2 here. So what I'm going to try to do is I'm going to try to pull out the largest multiple of 2 in the exponents underneath the radical sign. So I'm going to get something that looks like this. So I'm going to write x squared times x, like that. Because x squared times x, that's what x cubed means, right? I've got a total of 3 x's all multiplied with each other. And something that I'm going to make very clear in just a minute is that this is equal to, well, x squared times x, or I should say the square root of x squared times the square root of x. And what we've already found out with the first one is this is equal to the absolute value of x, and this is equal to just the square root of x. So that's it simplified. Okay. Are there any questions about this before we move forward? We're doing okay? Yeah, good. Okay. Okay. So before we move forward, I'm gonna write out a few rules. Okay. So let's do let's write some properties of radicals, because these are important. So properties of radicals. Okay, properties of radicals. Okay, so yeah, let's talk about these. So properties of radicals. Let's see here. So there's a few things that I want to point out. First of all is first of all we have this property that is a to the power of 1 over n. So if I have like an exponent that's a fraction, this is equal to the nth root of a. Okay, and there's a whole bunch of really cool things that you can talk about when it comes to fractional exponents, and it's something that we'll talk about as the days progress. But for now, this is all we need to know. Similarly, we'll have that a to the power of m over n. That is equal to the nth root of a to the power of m, like this, which is also equal to the nth power of a all to the power of m. So these all mean exactly the same thing. Okay. Next up, we have something, again, very similar to all of these. It'd be a to the power of negative m over n. That is equal to 1 over a to the power of m over n. And we've all already seen what that denominator looks like from the line above. But that would look something like this. The nth root of a all to the power of m. Okay. I think there was a couple other ones I wanted to show you. Let me just double check here. I had these all written out earlier, but then I closed the window for some reason. Come on. Yeah, I think that was it. Why can't I find these properties? Oh well. Yeah. If I think of another property that we need, then I'll write it down. But these are the main ones that I wanted to talk about. Okay, so let's jump right into some of these and start doing some kind of the more challenging examples. Okay, so I'm just going to start copying some of these questions from your textbook because these are really good questions. Okay, so we're going to convert from a mixed radical to entire radical. Okay, so let's talk a little bit about what a mixed radical is and what an entire radical is. So just as an aside, this would be a mixed radical because we have a whole number part right over here, and we would have an actual radical in red, whereas an entire radical would be if I were to take this one over here and convert it into a entire radical, I would get this a squared times b, and these two things are equal. These are the same. It's kind of like converting an improper fraction to a mixed number. It's almost exactly the same process too, actually. But the idea is that one of them we've sort of factored out the biggest square that we can, and it's outside of the radical, whereas on the other one, it's all just one big radical. So let's take a look at what some of these examples would look like. So if I had 7 times the square root of 2, well, I could write 7 as the square root of 49, and I would be multiplying that by 2. So these two things mean exactly the same thing, right? 7 is equal to the square root of 49, so 7 times the square root of 2 is the same thing as the square root of 49 times the square root of 2, which is equal to the square root of 49 times 2, or in other words, the square root of 98. Okay, so that would be converting from a mixed radical into an entire radical. Let's go backwards. Actually, no. Let's do one more example. I'm gonna do part C here because it's a little more challenging. So let's do change up the color. So let's do 5b times the square root of the cube root rather. The cube root of 3b squared. Okay, so we're going to convert this into an entire radical. So keep in mind that we're dealing with a cube root here. This is a cube root. So that means that I'm going to have to turn this into some kind of cube. So let's go ahead and do that. So this is going to be equal to, well, the 5b, what I'm going to do is I'm going to write this as 5b cubed, but then I'll take the cube root of it. So I'm hoping that you can see that that's the same thing as 5b. Oops, and I put the exponent in the wrong spot. There we go. So 5b cubed, all of that cubed, and then I take the cube root of that. That's the same thing as 5b. So I'm going to go ahead and I'm going to multiply that by the cube root of 3b squared. Okay, and maybe you can start to see where these little ticks at the end of a radical sign actually mean something. Just going to make sure that the chat is okay, everyone's doing fine. Okay, and now I'm going to combine these two radicals. So this is equal to the cube root of 5b to the power of 3 times 3b squared. And now I just have to expand everything. So I'm taking the cube root of, well, 5 to the power of 3 is 125. I've got b to the power of 3, b3, times b squared. Okay, and all of this is equal to the cube root of, well, 125 times 3 is, I think, 375. And b to the power of 3 times b to the power of 2 is b to the power of 5. And that's that. So yeah, that's pretty much it. I'll do a couple more examples. I think it'd be good if we could go the other way around, where we take an entire radical and convert it into a mixed radical. So let's do that next. So yeah, let's start off with the square root of 200. So we'll convert from entire radical rather. Entire radical to mixed. I should also point out that this process is called simplifying. A radical. So if you're ever asked to simplify a radical, that's what they mean, is to take the radical and convert it into a mixed radical. So you might have this big, huge radical, and the idea is that when we simplify, we want to take as much out of the radical as possible. So you'll see what I mean in just a second. So we'll do that with the square root of 200. Okay. So what I'm going to be looking for here, so I'll just write on the side, this is what we want to look for. We want to look for factors. We want to look for factors of 200 that are perfect squares. That are perfect squares. Okay, so we're looking for factors of 200 that are perfect squares. So the one that I see almost immediately is the number 100, right? 100 obviously goes into 200, goes in twice, and 100 is a perfect square. So right around now would be a great time to memorize some perfect squares. And I'll show you what I mean in just a second, but I'll finish this question first, and then I'll talk about perfect squares, and then I think that's going to be pretty much it. We're gonna end it at 315 today. So this is going to be the square root of 100 times 2, right? And that means that this is equal to the square root of 100 times the square root of 2. Okay, and the square root of 100 is just 10, and then the square root of 2 is just the square root of 2. I can't simplify the square root of 2 at all. So this would be that radical simplified, or in other words, I've taken the entire radical and I've converted it into a mixed radical. So we could call this two things. We could say that this is a mixed radical. We could also say that it has been simplified. Okay, so we've got a mixed radical and something that's been simplified. Okay, so I just want to talk very quickly about the perfect squares that I'd like you to memorize. So I'd like you to memorize these numbers. And it's too bad because in our classroom I actually had these numbers printed and they were actually outside, like on our walls, like physical versions of them. So if you want, you could print these out if you have a printer at home, or you could make them and draw them and make them look really pretty and put them in your bedroom so you just memorize them. But in any case, we do have to memorize these numbers. So we need to memorize 1 squared, obviously that's 1, 2 squared, that's 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. And these ones I kind of take for granted because these are in our times tables from 1 to 10, and I assume that you know your times tables. The ones that may take a little more work are these ones. So 11 squared is 121, and 12 squared is 144. We could also do 13 squared, which is 169. And I think at that point, I think that should probably be okay. If you want to go up a little bit higher, you can in terms of what you memorize, but this is kind of like your bare bones. This is what I absolutely need you to memorize. And we may look at some other values as well. But for today, why don't you take a minute just to memorize these numbers. I'm not going to assign any homework today, so this is, I guess, what I could consider this homework. So how about for homework, we say that you memorize the first 13 perfect squares, and like I really mean, like, you really do have to memorize them in the sense that, like, they need to just come like that. Like, you just need to be aware that these numbers are the perfect squares. So it's not so much that, like, oh yeah, there's 8 squared, which is 8 times 8, which is, 63, 64. No, I need you to know what the perfect squares are. Just like if I asked you, like, like if you're like a Game of Thrones fan, and I asked you, like, who the Starks are, you immediately would know who they are, and you could just say so. Now, with these ones, I just need you to know what these perfect squares are, and then you just have to know what they are, like, as if they're a part of you, okay? Because we need to be able to pull them out. We need to be able to factor them out of other big numbers. So it's not even so much that we want to recognize these numbers, it's that we want to be so familiar with these that we can recognize when another number has one as a factor, right? So if I gave you the number 72, you'd be able to say, oh yeah, I know 36 is a factor of 72, so we can factor out a 36, that kind of thing. Just looking at the chat, that's why I'm a little behind on the chat. So this square, this is a great question. The square, so before we go, I'm just going to answer this question because it's really good. So is the square root of x cubed, is that equal to x or absolute value of x? And I'm assuming, because it's hard to write this stuff on a keyboard, I'm assuming that there's supposed to be a cube, that we're taking the cube root of this and not just the square root. Because if it was the square root, then it wouldn't be either of these things. So is the cube root of x cubed equal to x, or is it equal to the absolute value of x? Well, let's figure it out for ourselves. Let's throw in some negatives in here and see what happens. So so this one right here. So if I were to ask, okay, what's the cube root? So let's say that x is equal to, let's make it easy for ourselves, and let's make this equal to -2. Let's see what happens if x is equal to -2. Well, -2 cubed is -8, and then the cube root of -8 is equal to -2, because that's the number that when you cube it, you get -8. So there is no absolute value here because we actually do need the possibility for negatives. So in this case, the cube root of x cubed is just x. It's not absolute value of x. It's just x. Okay. Okay. So yeah, like I said, as far as our schedule goes, I'm going to be doing 45-minute classes instead of our typical hour, just because it's these classes are a little bit different than our regular classes. Typically, you wouldn't see me just talking at you for a full hour. So we're gonna end it here. I'll still be online if you have any questions, but I'm gonna sort of end the live stream now. So yeah, if you have any questions, don't hesitate to ask. Make sure that you take a look at the website. Also, like I said before, I have 16 assignments. So I think that there's how many we have got 8 people on Discord and let's see, 8 people on YouTube. So maybe that's all 16 people. So maybe there's only 16 people in our class anymore. Yeah, if you can, please hand in that assignment because I'd like to mark them and return them, and I can't really do that until I've got all the assignments. So seeing as we have report cards coming up pretty soon, I am going to have to just make a hard cutoff date. Pardon me? I couldn't hear that. Anyway, yeah. So I'll still be online. So if you want to ask a question, you can do so. Otherwise, I'm gonna end the oh yeah, they said, and that's Gr11. I'm gonna end the stream here, and I'll sign in tomorrow, and I'll talk to you then. Oh yeah, what's the question? Yes. Yeah, there's a huge thing that's going on with what mathematicians like to call the parity of the index. And what parity means is odd or even. So when I'm talking about the parity of a number, I'm talking about whether or not it's odd or even. So the parity of the index has a lot to do with our process. And that's because if I multiply an odd number of negatives, I'll get a negative number back, right? Like -1 times -1 times -1, 3 negatives, I would get a -1 back. But if I did 4 negatives, like -1 times -1 times -1 times -1, I get a +1. So yeah, we'll talk about that tomorrow. But yeah, certainly the odd or evenness of our index has a lot to do with the process that we do when we're simplifying these radicals. A good question. Okay, anyone else? Okay, I'm gonna end it there. Make sure that you check the website for the updates, and make sure that you've handed in the assignment, because I would like to return them. So anyway, I'll talk to you guys tomorrow, and have a good night. Bye bye.